No, that's fair. That's fair. I know. I mean, we're keeping this at a reasonable level, right? Like we're gonna be doing it.
Yeah, yeah.
You know, what you
I'm
call it?
more, I'm
Intern
more like,
easy, right? Intern
in,
easy.
yeah, I'm more interested, especially like I never tried a question where someone just talks and you have to like take notes and do these kind of things. So that's
Yeah,
kind
yeah,
of
yeah. That's very
interesting and different.
common. That's very common for that kind of thing.
Yeah.
Let me just quickly. Okay. Okay. Well, we're live. So, I mean, let's just get into it then, shall we? So, what's your preferred language?
It's Python.
Python's your preferred language. Okay, Python. We are on Python. Great. I think I set my default to be Python, so most people are pretty comfortable with that.
Yeah.
Okay. All right. So, welcome to the mock interview. How these work is they're an hour long, and we'll just go right into the problems. Usually, in a real interview, there'd be some introductions and stuff, but we can skip that. We'll have 45 minutes or so for the actual problem, and I will help you manage the time. Although, of course, you are encouraged to, make sure you keep tabs on that as well. And then in the last 50 minutes or so, we'll go through feedback, any questions you have, etc. Okay.
Yeah.
Any questions about the format?
No, I'm ready.
Okay. All right. So I'll read out a prompt for you. You're free to pause and let me know if there's any concerns. And otherwise, I want to see how you want to walk through the kind of problem that we have present today. So the first problem,
Yeah.
I would like you to write me a function called remove duplicates. And the input to the function will be a string. And you are to return a string as an output. Okay. Now, what remove duplicates does exactly what it sounds, except in addition to removing the duplicate characters in the string, it also orders the string to be in the smallest lexicographic order.
Okay. So lexicographic means are we dealing only with alphabetic bars
Sorry, can you say that
like
again?
A to Z? Are we dealing with only
Yes, yes.
characters that are A to Z?
That's correct. Yes, that's
Yeah.
correct. Yes.
Okay. Are we also dealing with capital letters that could be in this initial string?
Nope, there's no capital, so you can assume they're all lowercase letters. Yeah.
How big is this string over here?
How big is the string? The string could
Initial
be,
string.
yeah, it could be quite large. It could be 10 to the 4 length.
Okay. Um, so when we're talking about removing duplicates,
Mm-hmm.
let's say we have an example that I'm writing here, A, B, C, A. What we're going to return is ABC, correct? Or would you be returning um, the other option, which is BCA? Is there any preference?
Yeah, so you were returning the smallest lexicographic of the two. So like between these two, what is
Oh
what
yeah,
is
okay.
smaller?
Oh yeah, I see. Okay.
Yeah.
Okay, I'm just gonna think for just 10 seconds here.
Yep.
Okay, so what I'm thinking about is that we are going to use a set, and in this set, as we're actually be using a pointer and a kind of a set of this original string. So how it's gonna work? Is it drawing?
Yep.
There's a drawing. See this? It's kind of small. Yeah. So if A, B, C, A could be a pointer that we'll start at A, we're gonna add it to a set. We're gonna go
Okay.
to B, we're gonna add it to the set. Um, if we see a duplicate, yeah, if we see a duplicate, then we're not gonna add it to this set, and we're gonna kind of skip past it. And that's it,
Okay.
whatever L. Um, yeah. Uh, yeah. Okay, so that would leave us with a possibility that we would have to sort it at the very end. So that would be n log n. for this entire removing of duplicates.
Okay.
Yeah, I'm just gonna think for another small period of time just to see if there's any maybe more time efficient way of dealing with this. Okay. Yeah, I don't think so. There's actually a way of making, because one of my initial thoughts was to use like a what do you call it, a heap, and that way you could, have at most the amount of unique, characters. But since we're dealing already with like unique characters, we know that the size of this of our result will always be under 26.
Mm-hmm.
So I do think no matter what we're dealing with, actually it would be it would be n. I believe it would be n. Yeah, yeah. This would be 26. So it'd be 26, and then obviously be no. It'll be log of n, because the max sorting that we're going to do is 26. That's the max like amount that we could sort. So technically, we could call that like linear time. Yeah, would we call it linear time? Yeah, I think we could call it linear time because it doesn't depend on the input size. All right, so I'm going to
Okay.
try coding this up, and if I see any quicker solutions, I will make a pivot.
Okay.
And I'm going to call it oops. And we're taking in a string. So we'll call this scene set. We'll set here, and then we're going to iterate over for the chars in keyword is it? This one. Or our string. We'll first, as we were showing, add it to the set.
Mm-hmm.
So, oops. Add the char. Wait. Yeah, I believe in Python the sets, if you try adding, if it already exists. Well, actually, I'm just gonna make a checker. If char not in set, we're gonna add the char. Yeah, and then continuing. Yeah, we're gonna keep doing that. We're trying to return a string here, so let me just make sure. I was just make a result called string actually, and for the append, let's append the char into our results string. I believe that's doable in Python.
I don't think that you can append onto a string.
Okay. Okay, then it's
yeah, I think that works.
Plus equals the char. Oh, yeah. One thing actually I should ask right here is I noticed that there could also be a empty string. Is this a possibility?
Oh yeah, it could be empty string. Yeah.
Okay. All right. So this would still work because this won't run, and then we're gonna at the very end return result. Oh, sorry. We're gonna result dot stored. Yeah, I believe. Oh, wait. Is okay. I'm just gonna use an array actually, and we're gonna go to append, and then we're gonna join it. Yeah. Oh, actually, sorry. No, we can say a string, and we can just. I'm just gonna do this. Result equals. Use turn to list, so we can use the sorting algorithm.
Okay.
And then from here, we're gonna do dot sort, and then we're gonna do res. I believe dot join. Join. Is it join?
What are you trying to do?
So I'm trying to. So we have. I sorted it, and we have basically a bunch of chars, like like such, or like A, B, C,
Yeah.
and I'm looking to like join them into becoming a string. I forgot the operation.
You can do it either with the string of the list, or you can do it
Oh,
as like that.
oh, I see, I see. Yeah, oops. Okay, I'll go with this option. Thank you.
Yep, no problem.
I'm just gonna think about one, example. I'm just gonna run through a test in my mind here. Fake test. So I have A, B, C, A, B. So what we're gonna do is we have a scene set. For each char, we're gonna be at A, and we're gonna realize that it's not in our set. We're gonna add A. Then here we're gonna add B. We add it to our thing. We add C. When we get to A, it's not in our thing, so we skip past it. When we get to this part, we get past it as well. And then in this particular example, it was already pre-sorted, but if it wasn't, we would sort it. And yeah, this seems to be my function here.
Okay. Okay. Are you happy with it?
Yeah, looks
All right.
good.
Space and time complexity, please.
Okay. So as I mentioned before, in terms of our time complexity, this sort is only going to be a max of sorting 26 possible characters. Oh, actually, sorry. Wait, just to confirm one last time, like this string does not contain any characters that are not
That's right.
alphabetic. Okay. But I did not have to do any checkers. So going back to that space and time complexity, it is O of n, because the 26 size is ignored, and it is also, in terms of our size, it's going to be O of 1, because this max of the size of the result is 26.
Okay.
Actually,
okay.
Yeah, 1, yeah.
That's true. Yeah, you can. Yeah. Okay. Okay. I'm happy to continue from here, so we can move on. So what we're doing here is I'm going to copy this code, so we won't touch this anymore, and then we'll work on the one below. Okay. So the problem there's a follow up now. Okay. Now the problem is as such. So we don't actually want to return the string in pure lexicographic order anymore. Now what we want to do is we want to return. So the same rule applies in that we want to remove duplicates. But now you can choose which duplicate to remove. So you can choose which duplicate to remove. Now, let's say we have an example here, or I'll give an example. let's give an example. And I'll give you an example, I mean I'm gonna go think of one by looking at the what I have here. Okay, here's an example. Let's go this string. Okay, so this string, you notice that there's two C's, obviously, right? Actually, we can use the example. There's two C's, obviously. So to remove that, you could either have CBA or BAC, right? Both of these have no duplicates, correct? Okay. So sorry.
Yeah. Yeah, we could also do ABC as well, correct?
We could, but that's not the point. So these two have no duplicates. Now, the reason that these two are the ones I picked is because they are substrings of the original string. So they are not, or subsequences, you can call them subsequences. So we did not reorder any elements. We only removed elements, right? And so now the rule is, hey, we want to remove the duplicates, but you can choose which duplicate to remove. But we remove the duplicates and return the resulting subsequence that is the lowest lexicographic order. So between these two, you would return you would return BAC because BAC is less than CBA.
Um, you said okay. But in this example, we have to have it be a substring. So that's the main difference between the last one. We still want
Yes.
the lowest lexicographic.
Among all the
Except it has to
substrings
be
that have no duplicates.
substring. Okay. Okay. So I'm just gonna run through a first example in my mind that might switch things up. So let's say we have like A, B, B, C, C. In this example, it's no longer possible to have the size of our thing being size 3. Example, like in this example, we are stuck with either AB or BC. Those are the only two options because those are the only two substrings that have sorry, no duplicates, correct?
Sorry, say it again. I missed that.
I'm just saying. So in the original example, we could
Yes.
in this example we would end up having a string result return that's size 3 because we would take A, B, and C.
That's
In our
correct, yeah.
example, the max we could do is size 2, right? It's only either A, B, or B, C.
No, because you still need to have an A. Right? So to remove the duplicates, you're removing one A, one B, and one C. Right?
Yeah.
So given that you're going to remove one A, B, C, what would be the lowest lexicographic result that you can have? Which in this case is pretty obviously ABC, right?
It would be A, B. Okay. That's where I'm a bit confused about.
Okay.
So this is not a substring of this at this moment.
I see what you mean. Yeah, it's not a substring, but it is a substring if you remove the right values. Right? Like.
Okay, if you move the right values. Okay, I see.
Right? Like for example, like this. If this was the answer, if this was the input, this would still be the 2 you would have. Because you can remove you remove one A, right? So you remove one A. It doesn't matter what you remove; it's the same result, right? And then you remove one C. So you can, if it helps you think about it, you can think of it as you can remove the duplicates in any order you want to result in the lowest lexicographic order.
Okay. I'm gonna think about this for another small period of time, quietly. I'm just gonna have to walk. I couldn't initially think of something right off the top of my head, but I'm just gonna walk through the example in my mind and see maybe its logic.
Okay.
So let's say we're at C. We then move on to B. We're adding it. We then move on to A. We add that. Uh, A is another. Doesn't change the order. When we get to C, we then get a second option. So when we're at C, we say, hey, this has been in our set already seen. Actually, I'm just go to this example here. Yeah, when we get to C, we realize it's in our set. So then we have to make a comparison. Um, do we either A remove the C and make this one, this back the case, or do we keep the CBA? So I think this could be like a lexical comparison that is done as we're iterating through the thing.
Okay.
And that will determine which one we're going to remove from our result. Are we going to remove this C or this one? So yeah, so I think this sorted is no longer be of use to us
Yeah, we won't be reordering it now.
because
Yeah.
we'll be doing a comparison. Okay. So for chars.
So I want to just clarify one thing here. So you're
Notes.
basically we just walked through over there. If I understood correctly, you're saying we're gonna have you're gonna walk through the string again, but if you encounter a duplicate, you're going to perform a lexicographic comparison between the two options. Is that
Yeah.
okay? Okay. Please continue.
Adding else. So this was it was a non-dupe. We just keep adding. If it's a dupe, yeah. If it's a dupe, well, there's that one example. Actually, I'll come back to it later. I'm just gonna write the example down. Okay. So in this example here, we're at CBA, and now we're going to be at the option of adding C. So our comparison is the current result, right? That's the current result, and the other option is removing. Is it always going to be the first char? I'm just going to write down another example. CBAB. In this example, we have the option between cab or bab. Those are the two options. And we choose bab. How could we lexically explain this?
Sorry, what would you choose?
Bab.
Where's your C gone?
Oh, you're right. Sorry. Between this example, we have there's cab or there is CBA.
Yes.
Okay. And then we would choose cab.
Yeah.
So let's compare. What we're doing is we're comparing the string that we currently have. So our result with an example where we've removed we removed the specific char that is in question, and we've re-added. Okay, this. Okay, I have a solution, but I think it might cause a different time complexity.
Yeah, it's going to be different. That's okay. I mean, getting it
Okay.
correct is more important than getting it efficient right now. So let's just focus on correctness.
Okay, but I will leave a note here of something. Okay. So yeah, we grab results. This is our second example. Remove. Actually, results. Copy. I'm just gonna call it. Oh, actually, we don't need to use the copy because it's still a string right now. So I'm just gonna call it compare. Results. I'll grab the compare thing, and we're going to dot remove prefix of whatever the char is. And then because we've reached at the end, it's going to be plus equals the char. Because it's always going to be at the end that we discover this new one. And then we're going to say if result, I believe, can you do a comparison like this? Or you have to, yeah,
Yeah, you can.
okay. All right, if this one is less, then we change the then result equals compare. I think this would work. Now we have, yeah, I think this would work.
Okay.
Okay. Does this seem legit? Does this seem correct?
Well, I want to understand your impression of what remove prefix does. Could you explain in your own words what does remove prefix do?
Remove prefix because we're looking for the specific char in the string, and then we are removing it. So in this example of tab, we encountered the B,
Yep.
and then we're gonna find in which was originally CBA right now. We'll find the B, we'll remove it, and then we are going to just have tab be the new thing.
Okay. Okay.
Now I mean I do believe this is a O of N operation. So because of that, the time complexity now switches to being this could happen virtually every single time that we need to keep on removing this random element. So this could happen this is O of N squared. A improvement to this, however, would be let's map instead of using a set, we'll use a hash map. We'll map the char, and we'll use the properties of a hash map that allows us to basically say if it's seen or not. So we'll use it in that case. And when we come to this case over here, we will just say what's the index of it. Let's pop that index. Yeah, let's pop that index. Let's shift all the index. Oh, that would be another operation. Okay. Yeah, that would, okay. Actually, I don't think so. From the top of my head, there's actually I can't think of currently a more efficient way.
Okay.
Yeah, I'm just gonna leave it at this.
Okay. That's fine. That's fine. Yeah. And does the space complexity here change at all?
No, because that matches we're gonna have 26 for our results. No
Okay.
duplicates.
And then I also want to get your take on this one. Like, what do you think? What do you think is the complexity of comparing two strings?
Very see. Yeah, because if it's matching, we have to keep on kind of shifting kind of this like pointer hypothetically if they're near identical except for the very end, we have to keep on like shifting a pointer. So that's another O of N operation. Okay. Do O of N.
Okay.
Is there yeah, and if you do max, that's equivalent, I believe. Yeah. Max would also be okay. Could I just think for maybe 30 seconds to see
Yeah,
if there's
sure.
a more optimized way of doing this?
Yep.
Okay, I'm gonna go through maybe a walkthrough drawing just to confirm
Okay.
another theory that may have. Let's say we have A, B, C, and then we'll have C. Actually, that's not an example. Let's go back to our other example. It is C, B, A, D. So what I'm thinking of is maybe there's a way of doing this with pointers and having a left pointer and a right pointer. So let's say we start at the beginning here and we would shift the right pointer. I would say, is this in our thing? No. So if that's the case, then we continue going forward and go to A. If it's in our thing, we add it. That's valid. Then we go to another a duplicate A. In this example, we say it isn't our thing, and so what we're gonna do is, well, we can for now we can just say if we'll just check the last index of our pointer, the previous one. If it's the same, we can just skip past it because we'll never need to add something at the very end like such because it's just replacing it with itself.
Yeah.
So we can skip past it. Now we get to see is the interesting part. Yeah, we get to C. So now we're at C, and most is a duplicate. And our yeah, we know this is a duplicate. So then we can move the pointer over here, and obviously that would give another option, and we have to make a comparison. So I mean, if we move the option like such, then the comparison now becomes this versus this, I believe. I believe that's the only comparison that matters at this point, which is not a string comparison. It's a two chars, which is much better, and as well as we don't have this remove prefix. We're not like popping. But now let's go through maybe a more hard example where it's not at the very front, like it would be C, B, A, B. So we get to this point over here, and then we get a B. Wait, let me get to. So we know that this pointer on the left is not the one. So maybe we skip past it. I'm just gonna think again for another 10 seconds.
Okay.
Here. Okay, so I'm now shifting my thoughts back to that hash map idea. So if we had a hash map, what we could do is, hey, what index is this B at? And what we'd say is, oh, it's at index 1 in this example. So we would take our kind of string and we kind of do like some string slicing. We'd say, hypothetically, if we just compared, the string slice plus AB versus our previous one, which is CBA. And this string slice would save us um, time. Would save us from doing a string comparison because, or we would still have to do a string comparison actually. Right? No, we wouldn't because we'd just be comparing the letter B, right? We have CBA. We'll be comparing if these remain the same. So I think we would be comparing everything past this string slice. Does this make am I making sense here? So we'll be comparing the B and the A. We will be ignoring what's before the string slice.
Yeah.
And that way, actually, it's not even before the string slice. I believe it's just these.
The string size itself. Yeah.
The first part of the string, I believe, is the comparison. Yeah, I'm sorry, writing.
It's going to be comparing. I mean, specifically, it's going to be comparing, like, is like, where's my pointer? Here. Wait, that's not my pointer. Where is my? Here it is. Yeah. I'll use a different color. I'll use the green. But like specifically, you're looking at this substring, right? And you want to know if like this substring is better than this substring, right? Like the two BA, like the two B's, right? Like you want to know which of the two substrings is better, right? Like if you like the string starts with C anyways, right? Like the string start like that's not part of the debate, right? The string starts with C, so you don't care about that, right? So you care is BA better or AB better?
Yeah.
Yeah. So yes, I think we meant to say was basically the same thing, which is, hey, do we look at like which B do we take, right?
Yeah.
And you determine that based on comparing, like BA or AB.
Yeah, I believe because the one that gets removed is going to be the same. Like every time we remove it, it's going to be at whatever index it is. We only have to compare the first one right after, I believe. Like after this string, whatever it be, even if it's like a bunch of E, D, L, whatever it is, we only would have to compare past that point and only the first char, I believe, because that's how kind of when you remove it. I think that's the case. I'm just gonna code it up here and if there are any discoveries along the way. Okay.
We can move to more pseudocode now if you have trouble with syntax or anything. So I don't mind.
Okay. I'll try to keep this I'll try to do legitimately without pseudo. Hash map equals this. We're gonna say instead of is it in the hash map? If it is, then what we're gonna do is we're gonna do hash map, the char, and we're also gonna set a enumerate. I believe it's the index first. Equals 1. Oh, sorry, equals I. So we're setting it when we're doing this, and then we're adding to the result. Then we're gonna do that's in the other example, we end up finding each other. We'll make a comparison where our compare CBA. So we're gonna find firstly find where we found a duplicate. So we're gonna get the index of that duplicate. Let's say dup index equals such. yeah, first we'll get the index of where the duplicate is, which is here. And then what we're going to do is we're going to compare basically if we did the string slicing, I believe this one. That means we stop at this end here. Is it? Yeah, we stop at this end, +1. Yeah, let me just walk through that example. So we find first the index, which is going to be, we found the index to be this. And then what we're going to compare is, we actually don't care about this like string slicing here. We compare, I believe, this point to our original one to whatever. Yeah, this is the dupe +1, not a range actually. The dupe +1 compared to what our char is. Not char. I'm just gonna say equal char just for the sake of logic. We're gonna do this. Yeah, and then we're gonna do we'll actually call compare to, and then we say if this specific char here is less than this one, then we're gonna do results equal. String slicing here. Result equals 0. In this example, we have to skip past 1, so we're skipping past this one, the duplicate index here. So it's plus, I believe, plus, yeah, +1. And I think this syntactically works. Yeah.
Okay. I'm just looking at your indexes there. So you're going from 0 to the index +1, which means that you want to include the index.
Oh yeah, no, we do not want to include the index here in this example. And in this example,
Yeah, okay.
we want the index.
Okay.
Oh, actually, no, here, it's not a range, so it's fine if you just do the actual index.
Yeah.
Yeah.
Okay. Let's wrap it up with just a quick time and space on this one, please.
So now I believe the time is of 1, and again, since all of this these comparisons and these substrings are only going to be max 26, I think it's of 1 space, so of n time and of 1 space.
For which?
The of n time
Okay.
for
Overall?
the
Okay.
comparison for
Okay.
time, and then the space is of 1.
Okay.
Yeah.
All right. So let's wrap it up here. Let's go to the post-game show. How do you feel?
I feel like I'm very slow. Like I'm very slow at like getting the problem into first, like just typing things out. I feel like typing things out, I feel I'm a bit slow, and I just feel like it's definitely like a problem that it didn't just like pop into my head. So I definitely felt that like preparation in terms of maybe
Yeah.
questions revolving around uh, this specifically could have
Mm-hmm.
been made. I kind of got duped up into thinking this is like uh, a two-pointer solution
Right.
right
Okay.
away,
Yeah.
and I actually like, to be honest, I'm not 100% sure that my I would not tell the interviewer this, but I would
Yeah. Yeah.
100% sure,
Yeah.
but this is completely working out
No,
here.
I'm pretty sure. I'm pretty sure it's wrong. Actually, we can talk about that.
Okay,
Obviously, as an interviewer, I also
yeah,
wouldn't tell you that as well in a real interview, but I'm pretty sure it's wrong. But we'll go over
yeah,
that.
yeah.
Okay, so I mean, my follow was actually whenever someone gets a question wrong, I always ask them how correct do you think it actually is. But I mean, you answered that, so that's cool.
No,
How correct do you think your
yeah.
space and time complexity analysis is?
I think the first example is good.
Okay. Okay, you think it's
And
linear?
I think in this example, obviously, I think my problem's wrong, so I don't know anymore.
I mean,
But
yeah, that's okay. But like, given
um,
what you've written down, right? Like, given what you written
I
down.
I was confident at the moment, in the moment of whatever my time and space complexity
Okay.
is.
Okay.
I
Cool.
wasn't confident in my second solution here, but I would say it could be false confidence. But
Yeah.
yeah,
Cool. Let me just quickly respond to a message. Give me a sec. Okay. Um, so let's talk about it. So this is a LeetCode problem. It's called remove duplicates. Actually, it's one of the few LeetCode problems that actually has two exact same problems. Yeah, so you can go find it later. There's two problems. One is called smallest subsequence of distinct characters, and the other one is called remove duplicate characters. Um, you can find that out later. You can do it for yourself in practice, right? You can go learn the optimal one. But this is an interesting problem because it's not actually a difficult problem per se, but it does require you to think about it, like to have foresight when you think about it, right? Like it requires you to slow down, really try to draw things out, and understand in your head completely what your solution algorithm will be before you start coding. This is one where you can't just like stumble into it accidentally and go like, oh wow, I just found the solution. That's very very unlikely, right? So, and I think there's a couple of good things you did there. Like the good thing is that you did clarify the prompt, you did see what's going on, you did try to draw things out, and that's a very strong thing. Then you should keep it up, right? Now I don't think you quite convince yourself of all the answers at the end, and I also don't think you drew out enough test cases, right? Like one thing you should be careful of is you don't want to lull yourself into a false sense of security, okay? Because you won't really know what all the edge cases are unless you confirm that you have covered like the right situations, right? For example, I haven't seen your solution before. I think it's a bit off, but I haven't seen it before, so I'm not 100% sure when I say this. But I don't think your solution really works if there's multiple duplicates. And I think that's something which, if you had drawn out, I think that would have been either I'm wrong or you're wrong. But like that, I think that would have been a pretty obvious case if you drew it out. And that kind of goes into the overall theme of these sort of problems, which is about. I mean, you and at the end, props to you. You did catch on that this is really an index kind of problem that you have to know what the indexes of things are because, obviously indexes are closely related to the lexicographic ordering, right? So I think the overall kind of theme here is that I think you can afford to spend more time on drawing things out, especially if you're not confident in your answers. Okay. A couple other things I want to talk about as well, just at a high level, is um, good to say that you're going to take a little time to think about things. I think that's good. One thing I will add on to that is if you're going to do that, I think it's also important to say why you're doing that. Like, oh, I think I'm pretty close to finding a solution in these cases. I want to just take a minute just to think about that, right? I think that's a lot more palatable than just saying, oh, I just need to think about this for 30 seconds, right? So just be aware of that. If you're always, and this is a common thing, I wrote this down twice in the notes, which is that it's okay to go silent. That's okay, but I think it's really important to kind of clarify what your immediate goals are. Like, what are you trying to accomplish here, right? And that's not just about going silent. That's just in general. Like, what are you trying to do right now? If you're drawing, that's pretty obvious. You're trying to understand the problem. But if you're just sitting there on the code and you're not really moving, then it's less obvious, right? So that's probably a point to improve in terms of the communication side. Any questions about that?
No, that makes sense. Yeah.
Okay. And then one thing I did want to say before I forget, I think this is quite important about just in general these kind of interviews, is about the time complexity and about the language. Like, how does the time complexity relate to the language? Now, again, this is going to depend on the language, but if you're going to choose to use Python, you better know what's going on with Python. Okay, so a couple of things noted here. Some small fish, like for example, you weren't too sure about how the sets worked. You don't need to. You can just add it in again. It's going to be fine, right? Like that's a small fish. I wrote
Yeah.
that. It's only a small time penalty to write that out, but again, that doesn't give the
Yeah. Yeah.
interviewer confidence. So especially if it's a Python role, then they're going to say, oh well, that's probably not great. If you're just using Python for interview purposes and the role is not in Python, that's probably going to be okay, right? But it's not a good look, right? So just be aware of that. Like this kind of stuff, people don't expect you to get stuck on. Okay, not stuck, but like to even think about. Um, and then the other thing about Python, and this is true for most languages, in fact, but definitely true for Python and all high-level languages, is string manipulation. Okay, string manipulation is a really important thing to understand because when you get it wrong, it shows that you don't have a deep knowledge about systems. And what do I mean by that? So whenever you alter a string, it doesn't just alter the array. Now, as you are aware, if you actually mouse over the variable res on like line 59, you can see that the type is a literal, it's a literal array of characters. Um, what does that mean? This is a literal array of, and you can see the character has no characters because your string is empty, right? Obviously, this is a mutable object. You cannot modify this string. Okay, and so whenever you're doing things like res plus equals char, what it's actually doing is allocating a new string with this at the end. And what that means is every time you perform a
Yeah.
string operation, it is a linear time operation. Okay,
Yeah. I see.
and so that's something which you really don't want to be caught out doing because I mean obviously that's very bad. That makes your complexity n squared. But also because whenever you're doing this, it should be avoided because you can easily make an array of characters, and that thing you can append to, right? So that's a pretty big
Yeah.
miss. That will get you dinged on. And by the way, that is also true for any string operation, including slicing, right? In fact, this one's actually doubly worse because this is a linear operation, this is a linear operation, and then the concatenation is a linear operation. So while it's still a linear operation, it's three linear operations disguised as one expression. So like you don't want to be caught out with it.
Okay, so maybe avoid strings for these kind of, slicing and things like this. Like just turn it into
Just use a
a
char array.
mutable
Yeah, you want to use the mutable such as a list,
array.
like
Yeah.
our char array, right? Yeah.
Yeah.
Right. That's quite important, right? Now, this case, it wouldn't have mattered because you're in squared anyways over here, but yeah, just be aware, right?
It's
Um,
definitely things like you.
Go ahead.
Sorry, but I was gonna say definitely things like you don't think about on like Leetcode.com or something because you're just like, oh, it succeeds. Oh, it succeeds.
Yeah, I mean,
Um,
Leetcode it's got a lot of problems. That's one of them. But yeah, like this is the kind of thing which shows that you don't act. I mean, look, I don't mean this as an offense. Obviously, you're a student, right?
no, no, no.
But
Say
this
it.
is
Say
also
it.
the case for
Yeah.
like people who come in not as students. If you come in here and you write this, I just know you don't know what's going on with programming just at all, right? Like this is just
Oh,
immediate
okay.
fail,
Okay.
because like not as to fail the interview, but as in like I know that you don't know what's going on in the real world because this is just
Okay.
not
Okay.
code, right? This is not code. This is just not code. Like you cannot be doing this, right?
Yeah. Yeah.
So or maybe you just write a lot of front end stuff and you don't know about performance. I guess that's possible, but
No.
like
Yeah. No.
so that kind of stuff
No. I need to know this kind of stuff. Yeah.
yeah, I mean you should know it, and now you do know it. So there you go, right? There is real feedback for you, so you can improve on that. Okay, let me just see my notes. Okay, so string size comparison is correct. Yeah, so yeah, and this obviously affects your complexity for the follow up as well, right? So be aware of that. But that's all the notes I had. So I mean, there's some minutes here for you to ask any question that you wanna bring up, any concerns. It could be about this interview performance. It could be in general about interviews. Anything of that sort is fine.
Yeah. I ask one question is, how was just like my talking in general overall?
The talking is fine. I think, like I said, a couple of things you could improve on there is if you're going to go silent, be very clear what your goal is.
Okay.
What are you trying to think about precisely? And that is that well, but that's applicable outside of just being silent. But that's especially true when you're being silent because, right, then you have no information sent to the interviewer, and so they're going to be questioning what's going on. So I say that's the biggest part
Yeah.
that stood out to
Yeah.
me in this problem.
And for the actual like like logic part of the solution. Did it
Hmm.
make sense what I was doing? Obviously
Yeah.
these red flags are
Yeah,
here, but with
yeah, I
this
think that
like
was well. I think that was well done. I think at least that part I understood what you were trying to do. I think the drawing really helped, especially with the slicing at the end there. I can imagine if you didn't do the drawing, I wouldn't have corrected your off by one index because I wouldn't have understood what you were trying to do. So, in that sense, I think
okay.
that was well done. Yeah.
Would the problem be solved if I was using uh uh I was using lists instead of strings?
That's
Would that be like solvable, or is it still wrong, I
no,
think,
it's
for me?
I mean, it's solvable even without the optimal solution. But the one of the key insights that you did miss is that you need the last index of every character, which is what you actually need to compare against. But um, that doesn't require you to have a string or a list or a hash set. You can do it any way you want. But I think the canonical way is that you need to recognize that this is a pretty common stack problem. And so without
Um,
like regardless of a list, you can use a list as a stack. Obviously, you could also use it not as a stack. So um, it's not really dependent on that. It's more or it's more just general algorithmic differences. Yeah.
yeah, yeah, yeah. The thing is, the funny thing is, I was thinking about this right here. I don't know if you noticed. I think at one point, I don't know, I wrote like res dot copy or something. Because I was thinking of it as like a list, and then I realized like no, we don't want to like copy
Yeah,
and
you did do res.append at
something.
some point, but the reason that like
Yeah,
if you just try that,
no,
you can't do that. Like even though like res is
yeah,
technically a list of if you mouse over it, it's a list of characters. It's a literal list of characters, which means that the append function is
yeah,
not it's not accessible for literals because it's immutable. So I told you that you
okay,
cannot append, which I didn't mean to say you shouldn't append in general, but you can append to strings is what I
yeah,
mean.
yeah, yeah, yeah. Okay. I think I need to go through like those string problems. I don't think so. I do many string problems either. Like I just kind of yeah.
Yeah, no, that's
So
not a
I
bad
need
idea.
to work on that for sure.
Cool. Any other
Right.
questions?
Um, no, I think it's very helpful. Thank you for what you do. Help me like I know what I need to go forward and work on now. And yeah, thank you so much.
You are very welcome, UFC student. Take care.
Yeah, take care.
All right, interview done. Send them the notes, and then we're gonna move on to the mock and to not to the mock to the resume reviews here. So, um, let's get in it. We're a bit early right now, so I'm gonna wait a bit, but I'm gonna just put the links up for you. Put the link up. Close that out. That should be okay. That should be okay. And then if I go to this link, it should be okay. Yeah, I think this is a link. So there we go. Submit resume. Go ahead, pin that. Pin that. Unable to pin. Something went wrong. Average software experience. Oh, someone asked a question. How would you solve that problem? It's a Leetcode problem, so I won't go through it here because it's time for resume reviews. But um, you don't need a stack. You could do it other ways as well. Like this person was basically trying to use a stack. Like they were basically trying to use one. They just didn't quite get there. So that's why I brought up the stack solution as one of the optimal versions. But you could do it recursively as well. That's also valid. Um, Obviously, recursively, you use a call stack as a stack. So it's similar, but people think differently. So some people might use a literal stack. Some people might use recursion. There's a lot of different ways to do it. But the key is that you would push things onto the stack as you traverse basically, and then after you finish find like a duplicate, you find something that you want to pop off, or find like a character that's already in the visited set, or in this case it's a visited set. In the other case, it's if it's in the string already in the stack already, then you can just go ahead and compare against the end of the stack, which is the earliest. And then if it's earlier, you pop it. If it's not earlier, you just append it to the result array. So basically, it's using the stack as a way to track implicit lexicographical order. I did allude to it in the description, saying that, hey, you're either comparing. I think it was over here. You're either comparing over here. It's BA or AB. That's what the stack will let you to do. Is you can choose, hey, this is the B would be the front of the stack, would be the front, and we want to compare against, hey, is B going to be what we want to consider? Do we want to pop this B or take the other B? So that's kind of the stack there. But yeah, the problems on Leetcode, I recommend you read through that if you want to have a more detailed understanding. The volume is kind of low. Okay, noted. I'll improve that. I'll improve that for next time. And then let me see. Write a little note here. Submit resumes on pinned comment back at 1:05. All right, guys, entertain yourselves for a minute. All right, let's get on it. Let's see. What do we have today? What do we have today? That's some stuff. Okay. 12 and 19. Bit early, but you know we can spare some time for you. Let's take a look. Take a look. Boom, put it here. Why not? Okay. Okay. Graduated December 2024. Computer engineering masters. Looking for MLAI. Okay, went for SDE1 at Amazon Vancouver, failed. Hoping to get resume review. Okay. Applied new grad software in Ontario as well. Advice for projects. Okay. You're going for AI ML, but you are also going for SDE. That's kind of interesting. Okay. Projects. Oh, there's no experience. It's all projects. Okay, I see. Okay. Okay. Okay, I see. This is the resume you're using for. You've been district apply for a new grad on software engineering roles. Okay. There's no software engineering on this resume though. This is all ML, right? This is pure ML. This is pure ML. This is a mobile app with ML. This is pure ML. This is pure ML, right? So your only engineering here is you have an Android app. You have a full stack, basically a MERN stack. What is this? Is this MERN? What's your database? I don't know. There's no database here. Okay, interesting. Basically a MERN stack. So in terms of software engineering, there's no software engineering here. It's pretty sparse. So I would say make 2 resumes. Make a resume for ML. Make one for software engineering. I can't tell you much about the software engineering side. I can tell you that on the ML side, I can't tell you on the software engineering side, you probably want a bit more software stuff on the back end. Right now, I'm not seeing much back end. For example, this one, there's no back end. It's a sensor app. There's really nothing here, to be honest. This one, there is a back end on Node Express, but there's no discussion about the back end at all. So the products seem to be okay for ML. I'm not too familiar with ML, so I can't comment on how good these products are. But the products for software are quite lacking. So in general, just make more of that or break that to a separate resume and actually put some information about them. I mean, I don't even know these people who submitted these are here anymore, so I want to just speedrun these because I don't expect them to be here. Software. Oh, Indian. Okay. So I don't know about Indian, so I can't help much, but I'll see what I can see. Scalable. Quantify that. Engineer property upload endpoints. So the first okay. I will quantify that. I would quantify that for a project. Like this is experience. This is like a project that you worked on front end for. Yeah, I guess I just don't believe that using React would boost user satisfaction. Would boost user satisfaction. I feel like we're using Angular before. We're using raw HTML. If you're using raw HTML, then yeah, I can believe that. But there's like this is relative, right? Boosting is relative, and there's no relative for me to compare against. And motion detector. Okay, wait, what are you doing? You're doing software? Then this is a bad project. It doesn't show any software. Use events. Okay, MERN stack. Okay, some API stuff. Pretty basic though. Pretty basic. Live. Yeah, I'd say in general you need to put in more, like some deeper projects. If you're in fourth year Indian, you should be able to put in some more like complex stuff in here. I would say in general priorities also matter. For example, your most recent project, which is actually your most recent piece of work, is ML, and you're not going for ML. So this is just not relevant at all. Okay, next. Oh, resolution. Guys, we have resolution today. Holy shit. I'll recognize that name. Okay. So, oh, they actually wrote some fucking shit too, guys. This is fucking done. General software engineer internship, big tech. You reviewed resume several times, giving ideas and feedback. Based on that, made these updates. Following highlights. First experience bullet 2. Okay. Okay. Second experience bullet 3. Added C++ and Java to showcase OPE. Okay. Oh, you mean over here? Oh, you mean over here? Okay. Do you have Java C++? Okay, I see. Okay. Let's see. 2 billion monthly calls. 2 million per month, 2 per second. Okay. How many seconds in month? So 1 per second. I probably wouldn't use that as a quantification. 1 request per second is kind of, I don't know. I would maybe try to quantify that as like a burst API load instead, right? Like how much could it handle? Like what is the max you've handled per second? That could be a better data point. As of right now, 1 API request per second doesn't justify any of this, right? So keep that in mind. Blah blah. I like that. That's good. I mean, the point is still good. I just want to use that quantification. And this is the same as before. Okay. No, I think it is an improvement. I think it's a marginal improvement, but I think it's still an improvement. So I think that's fine. Yeah, numbers game. Obviously I'm looking at, so Detroit startup. Decent tech, pretty serious tech. That's pretty good. This is startup in Lexington. Lexington is a city I've only heard in history books. So congratulations for being the first person I've ever interacted with in any way from Lexington. I think the resume is fine, to be honest. I think the rest is just a numbers game and networking. Try to increase your conversion per application. Yeah, resume is pretty strong though. Won't cap. Okay, let's take a look. This guy. Okay. Any suite 2026 summer backend pref. Okay. This is a very competitive resume. I agree. I think this one is quite competitive. I agree. Like the stuff I'm talking about are just nitpicks, right? There's nitpicks. I agree with that. Oh, my elbow. Just fucking banged my elbow. Fuck me. Oh, shit. Okay. Incoming. Yeah, that's fine. Safe. Oh, this is Vancouver. Welcome. Hey, how's it going? Ruby, Rails, Angular, 25,000 users, backend. What is this? This is like 4 months, 3 months, 4 months. SSO, developing, so it's ongoing. I like that. You feel like you said across 4 products. Okay. Build a dashboard, manage stuff. Okay. Right, but you have a year of experience coming into this, and you're here for 4 months. Okay, I think this is the right tier. I think this is about the right tier. I think this is fine. This I think is a far more impactful project than this. So I think by the end of your internship, you'll hopefully have some more stuff to talk about the SSO stuff. Okay, you're at a startup. Let's take a look. Centralized patient dashboard, Django. Okay. Automated validation, ingestion, medical records into Python, artists can comment entry points. Okay, that's impactful. I like that. Resolve UI functional bugs, Selenium. That's whatever. Okay, projects tracking. Oh, okay. I this one I remember. I remember this resume now. Okay. Um. Okay. Okay. Yeah, I think this is a fine project. Yeah, I think this is fine. This is pretty cool, pretty unique. Okay, student team, Flutter app. Okay, okay. Okay. Student app, okay. Or we're here for a year though. You're here for a year though. Yeah, I think this can be pretty big. Specifically, I think you could clarify potentially about what you specifically done. Like I think, this is good to talk about, overall the team's done this. If this is the only thing you've done in a year, I would say that's a bit suspicious to be honest, but it is a volunteer kind of thing though, so maybe it's not suspicious. That's fine. Blah blah blah. That's fine. That's fine. Okay. What was your comment? Prefer backend. Okay, backend. Let's say you're a backend. Go, Kafka, Ruby, Django. You have some performance stuff over here. I think it's okay for backend. Yeah, I think that's realistic. I think that's fine. Yeah, I think you're not delusional. Okay, next. All right. Backend, full stack, web primarily. Focusing on breadth instead of depth ownership so far. Okay, that's good. I like that. Okay. How much do you have experience? You have experience. I will not put these in here anymore. Blah blah. Well, I mean, you forgot to redact it, so I don't know, man. Blah blah. Okay, okay, okay. Test profession, coverage. Okay. PHP, OpenAI. You don't see that in a sentence. What the fuck? I mean, I guess that's legal. Okay. A text dependency. Okay, sure. Okay. Update a sidebar tabs and blah blah blah. Okay. 8% through position parallel execution. Okay. I can believe that. Yep, I can believe that. Script performance. I would maybe be more. This is a nit. I would maybe be a bit more specific here and quantify performance in terms of throughput or latency or any other metrics than just generic performance. I don't think it really matters though. Web server, postal codes, fuzzy searching Levenstein, fine. Blah 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 blah. I mean, like this is a while ago now. I don't even care about that anymore. You can probably just get rid of that. QA analyst. When you get this stuff in there, I just delete that. Boba share, Boba talks. Oh, Boba talks, nice. Fine, sip and play, blah blah. This is fine. Like this is the kind of room I would expect you to have, right? Like putting in 1 line, 2 lines, blah blah. Call it a day. I will put AWS here for ATS, AWS, GCP, ATS, just in case. Some like shitty companies, they don't have good ATS, so just put it in there. Yeah, otherwise, obviously it's gonna improve drastically with your most recent experience, but yeah, still more to do. Still more to do. Come back in a couple months, we'll see how it is. Robotics, computer vision. I thought I already reviewed this one, no? Linking, worried about bullet points not making sense. Wondering, linking on our personal portfolio. If you're going for robotics and computer vision, portfolios don't really matter. I mean, it's better if you have links. Like usually you have like design team and stuff, right? They gave you a link here. That's good. These links are better than just having, like these links are more important than having a portfolio. But if you have a portfolio with these links, that could be good as well. But generally speaking, I'd say if you're going for computer vision, robotics, don't worry about it. It doesn't matter. The bullet points make sense. Did I not review this already? I'm pretty sure I have. Yes, the bullet points make sense. You're fine. This person has their name and their phone number and their GitHub and their email and their LinkedIn. Let me see, where are they from? Ah, I see. Okay, won't review that. How about this one? The same. My guys, I will once again do this to you. Guys, can someone tell me, is this question ambiguous? Like maybe I'm the illiterate one. I feel like I'm illiterate now. You know what I mean? This is a mandatory question. Required. It's a required question. Okay? People just click it. Oh, I'm on the editing tab. I can't even like submit it, but people just click it and then they just submit. I confirm I have redacted all my personal information. Okay. Anyways, that's all the resumes, so I'll give you guys like a couple minutes to submit if you haven't already. And otherwise, I am going to be calling it a day. Thank you for your service. You're welcome, Leetcode Bytes. Your name looks familiar. Do I know you? Let me look at your channel. Leetcode Bytes. Your profile doesn't look familiar. Some leet codes on the channel. Nice. Keep it up. Keep it up. Oh. Two weeks ago you were commenting. Oh, that's probably why I recognize your name then. Yeah. Oh yeah, they're talking about a mock, right? So that's probably what's going on. Holy cow. Another one. I confirm I've redacted all my personal information. Your name is actually in such a big font, I can see your name on the preview. I don't even need to open it. Alright, I think those guys maybe don't speak English or something, that's fine. Python do portable stuff. I actually don't remember that conversation. I'm sorry. But I'm sure it was a good conversation. Anyways, it seems like there's no more people capable of reading the instructions, so I'm going to call the stream here. Thank you all for attending, and